Hi everyone, I'm Verian. I'm a scientist at Latigrid International. In this opportunity, I will present our work in the area of 3D construction printing, including method to improve the bonding adhesion of the cold joints. This method that we developed in our lab was eventually applied in our 3D house project in Dubai. The house itself was printed by 3D Vinci Creations using Latigrid's material. In this presentation, we will discuss about what is 3D printing and why this technique has been gaining its popularity in construction area. Moreover, I will present the design aspect in formulating 3D printing materials, test results of the materials, and on the cold joints. I will also present our journey of scaling up our materials from lab scale to construction. So what is 3D printing? 3D printing is basically a method to build a structure by using 3D printer from a 3D model. So initially we generate the 3D model using 3D software and then slice the model, and the slicing will generate G-code, which is used as the input file for the delivery system, which consists of the printer, the pump, and also the mixer. The materials are mixed in the mixer and then pumped to the printer. As the result is the 3D printed structure, which is basically the clone version of the 3D model. And all of these are controlled by using a computer. There are many potential benefits coming from 3D construction printing as compared to the traditional construction method. First is that 3D construction printing is more efficient than the conventional construction way. Less manpower is needed, as most of the jobs are done by the printer. With less people in the job site, it creates a safer working environment. Moreover, 3D construction printing also can expedite the project significantly. By using 3D printing technique, one can optimize the structural design by only allocating the materials where it is needed in the structure. For example, in the picture, the 3D printed stairs requires less materials than its counterpart made by precasting. By 3D printing structure, we can eliminate the need for formwork, as the materials can hold its shape once it's been deposited by the printer. 3D printing also enables us to create complex structures as presented in the pictures. Now imagine that build all of this structure in old ways. We may need to make the molds, which are expensive and will prolong the construction time. In the future, 3D printing also have the potential to be used to build human settlements outside the Earth. At Latigrid, we carefully design our materials to assure that we only produce the best quality materials. Our 3D mortar are designed to be printable, easy to use and adapt to various types of 3D printers, pumps, and environments. We can design the materials accordingly to satisfy and surpass the requirement of the project. For example, we can design the 20 MPa and 40 MPa strength of materials. We also design the materials based on the location. Our team is also thinking ahead in formulating our materials by considering its durability aspect, like the permeability, shrinkage, and freeze-stop performance. Our innovation in this area also extends to the design in various weight, color, and texture. Last but not the least, our products are cost competitive while maintaining its quality. Two types of 3D printing mortars were developed in our lab, normal weight and lightweight. In this slide, we can see the test results of the fresh and mechanical properties and the freeze-stop performance of both materials. The lightweight 3D mortar is found to be less viscous than its normal weight counterpart, despite for having comparable water percentage ratio. In terms of the strength, the normal weight has slightly higher compressive strength than the lightweight mortar. With regard to the freeze-stop performance, the normal weight material has performed excellence by having relative dynamic modulus of elasticity above 95% after 350 cycles. The lightweight material, however, did not survive the freeze-thaw test, which indicate this material is not suitable to be used in the area where winter exists. In addition to those tests, we assess the printability of our materials by conducting lab-scale 3D printer using a desktop 3D printer that we modified. As the results can be seen that both lightweight and normal weight materials are printable. When we print a large area, which commonly happens in the project, sometimes it is unavoidable to have cold joints. In 3D construction printing, a cold joint is a plane of weakness in mortar or concrete caused by an interruption or delay in the printing. It occurs when the first batch of mortar has begun to set before the next batch is printed on the top of the first batch, so that the two batches do not intermix. For example, here, if we want to print Arc the Triumph, we may not be able to print it in one run, but instead we would print it in several steps within an extended time. For example, we may print 1 to 2 meters tall per day and then continue the print the next day and so on until the structure is completed. In this case, the interface between two layers that are printed at different days acts as cold joint. To assess the interlayer adhesion between printed layers, we developed a direct tensile test on the printed specimens. Some of the specimens were printed in one run, meaning no cold joint exists. The other specimens were printed with a one-day interval between the lower and upper parts, creating a cold joint between the two parts. For the cold joint specimens, the cold joints were either treated with an adhesive or left as it is. When it is treated with an adhesive, a thin layer of adhesive about 1 millimeter thick or less was applied on the top surface of the lower part right before the upper part is printed. The adhesive needs to be fresh to be effectively adhere to the layers when we print the upper part specimens. The tensile force is applied perpendicular to the printing direction. The loading rate is 5 mm per minute. In order to improve the grip between the specimens and the gripping plates, we applied epoxy at both tips of the specimens. The surfaces of this epoxy were also roughened to improve the grip when it is hooked to the testing apparatus. The test results indicate that the normal weight materials has better interlayer adhesion than the lightweight. The bonding strength between the layers also found to increase as the specimens aging. When the cold joint exists and it is not treated, most of the times the failure plane occurs at the cold joint. However, treating the cold joint using adhesive improves the interlayer bonding strength of the cold joint. This can be seen from the reduction of percent failure occurs at the cold joint when it is treated. From the lab tests, we enlarged our work by conducting field trials. We collaborated with several 3D construction companies at different places to test the robustness of our materials when it's handled by different teams and subjected to different types of printer. Furthermore, here we can see the field trials in Dubai and also in India. So the materials used in these two field trials were produced locally using local raw materials. From the field trial, we finally scale up to construction projects. The first project is DE Stress, a 3D printing concrete pavilion designed by Dr. Christopher Battaglia from Ball State University, which was part of Columbus Exhibit 2019. The pavilion consists of 110 printed panels. The second project that we have done is a 3D printed house in Dubai, printed by 3D Vinci Creations using materials from Laticrete. The materials used are local materials that are available in Dubai and is designed to be able to withstand the local environment. The walls of the house are printed within 90 hours. The cold joints of the walls are treated with the same adhesive we use in the lab, which I presented previously. The adhesive that we use is Laticrete 254 Platinum Multipurpose Thin Set Mortar. At the moment, the project is near to its final completion. With the multi-benefits of 3D printing in construction, from creating a more sustainable construction method to fastening the construction time, creating a safer workplace as well as enabling us to build complex structure in a more efficient fashion, 3D printing is one of the futures of construction. Both of our mortar can be used for 3D printing. The normal weight can be used in most of the region in the globe, while the current lightweight is suggested only to be used in the area where winter is not part of the season. Regarding the cold join, indeed it is a weak point, especially in tension. However, the interlayer adhesion of the cold join can be improved by applying an adhesive between the layers. There's still plenty of room for innovation in 3D construction printing. As the construction with the 3D construction printing become more and more common, our understanding in this area should be also be improved. From creating a better, highly sustainable and durable materials, to improving or creating a better control printer and the overall delivery system. New grounds of structural design and building codes may need to be established to incorporate and guide the development and application of 3D printing. And here are the references that I use in this presentation. We are finally at the end of this presentation. Thank you for your attention, and I hope the information shared can benefit all of us. For questions, please contact myself as my email is shown below. Thank you.